You fire a projectile 35 degrees above horizontal with an initial velocity of 200 meters per second. It lands in a valley 300 meters below the launch point. What is the time of flight of the projectile and what is the range? Remember, you project a projectile above the horizontal with an initial velocity of 200. It lands in a valley. So meaning like you throw it from somewhere at the top, and then you had to release this projectile like that, and then it went down. Okay, the angle at which we had thrown this one is the 35. The height of this valley below the valley, that's 300, like from the top of the throw. What is the time of flight? So the time of flight is the time taken for you to release the ball from the very point of throw to the very bottom. You can use two methods. Let me show you both of them. You can pick one of them that you'd love. You can say height is equal to ut plus half gt squared. Now remember, because height is given as a difference, the final point is the bottom right, that's 0. The initial point is 300 meters from the ground, so that is 300. That's why we always use the negative value of the height when it comes to this kind of projectile. And then the initial velocity in the y is going to be, the velocity for the projectile is 200, so that is 200 sin the angle is 35. You always use velocities in the y when we are talking about height, and then this will be times time. But because the projectile first went up, gravity is going to be negative, so that will be negative half, where the Jew put 9.8, and then we have got t squared. So this is negative 300 is equal to 200 sine of 35. That will be 114.7152 t, and then minus 4.9 t squared. I'll take these terms the other side, so the 4.9 will become now positive, and then the 114.7152 t is going to become negative. You also have a negative 300 that side, and this is equal to 0. Now use the quadratic equation. T is equal to negative b. Negative b is the number that is in front of the t, that is negative 114.7152, plus or minus the square root of b squared, the same negative 114.7152. You square it, minus 4ac. A is 4.9, c is negative 300. Supposed to divide everything by 2a, and a is 4.9. Remember, this is square root. So this is going to give us t being equal to 114.7152 plus or minus. If you punch negative 114.715 squared minus 4 times 4.9 times negative 300, and then you can even square root that, is going to give you 137.9839741, down 2 times 4.9, that would be 9.8. Again, I said that you don't use the negative here, right? 114 minus 137, it will give you a negative number. Time should always be positive, so just use a positive. So 114 plus 137, and then divide by 9.8. Please avoid rounding off before the final answer. At least you can see I rounded off to at least 4 significant figures. It will give you a much accurate answer than you rounding off very early. So if you punch 114.7152 plus 137 divided by 9.8, you are going to get your time as 25.7856 seconds. This is when you use the direct formula. But you know, there are more than one way to kill. Is it a rat or a cat? So we can use equation 2 to be able to find the same time. But for equation 2, we have to first know the time it will take the projectile to move from the point at which it is to the maximum point, and then how to move from the maximum point to reach the bottom. So we are basically finding T1 and T2. So T1 is going to be able to reach at this point That will be T1. And then T2 will be from the maximum point to the very bottom. So to find T1, we can say V is equal to U plus GT. Now we are talking about in the Y because this thing is going upwards. So the final velocity in the Y at the maximum point is 0. The initial velocity in the Y is given by 200 sine 35. Because we are going upwards, G is going to be negative 9.8, and then we have got, I'll take this guy this side, so that will be 9.8. T is equal to, we punch now 200 sine 35, that will give us 114.7152. And this is actually T1. We just want now to divide by 9.8, and that is going to give us 11.7056. This is in seconds. So to find T2 now, we are moving again from the maximum point here. So now for the second part, the maximum point, this is what will be the initial speed. Because in this case, the final speed is going to be at the bottom here. Okay, that will be the final speed in the Y. So this will be initial speed in the Y. The initial speed in this case is going to be 0. But I don't know the final speed in the Y, so I'm not going to use an equation that has got a final speed. Instead, I can say, what equation can I use? I can say H is equal to UT plus half GT squared. This is the only equation that doesn't have final velocity in it. But you can see, for me to use this equation, I need to know the height from the very top to the very bottom, meaning that I need to find this height here. How do I do that? I'm going to say 2gh is equal to v squared minus u squared. That will be 2, because we threw the projectile upwards. Gravity is going to be negative 9.8 times h is equal to the final velocity at the top, right, is 0. Initial velocity, remember, we're using in the Y. This is going to be, I've been calculating the initial velocity in the Y for long. That's 114, or you simply say 200 sine 35. You square that. This is a negative 19.6, and that will be equal to 200 sine 35, and then we square that. That is giving us 13159.597. We are now, this is supposed to having h, so we're now dividing both sides by 19.6. That is going to give us 671.408. So this is just a height that it is going to cover going upward. So therefore, the total height from the very top here to the very bottom here, you add. So to this 671, add the 300. And that's the height that we want to use. So where there is h, we are going to put 300. Sorry, not 300, but the sum of 300 and the 671. That is going to give us 971.408. I'm not attaching a negative on this one. The reason as to why I am not attaching a negative is because we are considering this coming from the top. Of course, we can put a negative unless we alter the equation the way I want to work with it. But let me put a positive there. And then I'll say the initial velocity there is 0. So this is going to be 0 times 2, which is 0. Because we're considering from the top, right? That's the initial. And then we're going to have half G. I'm going to take it as positive 9.8 because I've taken this guy, the height, to be positive also. If I took the height as negative, I'll take G as negative also. And then times T squared. So it'll be 971.408 is equal to 4.9 T squared. 2 squared will be 971.4 divided by 4.9, and that is going to be 198.2465. Square root, remember this is actually t2 the second time. Square root now this value, it is going to give us a 14.08 seconds. So to find the total time of flight now, you add 11.705 plus 14. So 14.08 plus 11.7056, and this is has given me a total time after adding T1 and T2 of 25.7856. So you see exactly the same. So anyone know the formulas that you decide to use, it's up to you. They will give you the same for max. And then second part of the question was saying, what is the range of the projectile? The range is this horizontal distance that is covered. Now range is given by velocity in the x multiplied by the time. Velocity in the x is given by 200 cosine, the angle is 35, and then multiplied by the total time of flight. Total time of flight here is 25.7856. So if we get to punch that on our calculators, we should be able to get 4,224.47 meters.